The accelerating expansion mystery. Look up at the night sky. What do you see? A static, timeless tapestry? A collection of distant, peaceful lights? It feels that way, doesn't it? It feels eternal, constant. But that is one of the greatest illusions our senses have ever presented to us. The truth is far more terrifying, far more magnificent, and it's a truth that, just a few decades ago, would have been considered the stuff of science fiction. The cosmos is not static. It is not merely expanding. It is running away from us. And the force behind this great escape is the greatest mystery in all of science. Welcome to the mystery of the accelerating universe. To understand just how strange this is, we have to take a step back. We need to talk about the greatest story ever told, the story of the universe. For nearly a century, we've known the universe began in a single, unimaginable moment of creation, the Big Bang, a seed of infinite potential, hotter and denser than anything we can conceive. And from that seed, space and time themselves blossomed forth. Everything, every star, every planet, every single one of us is made from the ashes of that first great fire. And in that initial explosive rush, the universe began to expand. Think of it like this. The fabric of space-time itself is stretching. The galaxies are like glitter glued onto a vast cosmic balloon. As you inflate the balloon, the glitter spots all move away from each other. This was the established, beautiful picture. A universe born in fire, cooling, forming galaxies, and coasting outward on the momentum of its own birth. The logical assumption was that this expansion was slowing down. Why? Because of gravity, the great cosmic glue. Every single piece of matter in the universe pulls on every other piece. All those galaxies, all that dark matter, all that stuff, their collective gravity should be acting like a brake, gently pulling the universe back together, slowing down its frantic initial sprint. It made perfect sense. It was elegant. It was comforting, in a way. A universe that might one day, in trillions of years, perhaps even stop expanding and begin to collapse back in on itself in a big crunch. A cosmic cycle of birth and death. But the universe, it seems, doesn't care for our comforting stories. In the late 1990s, two separate teams of astronomers, led by the fiercest of cosmic detectives, were doing what seemed like a simple, if not Herculean, task. They were looking at the faint, ghostly remnants of dying stars, explosions called Type 1, a supernovae. These explosions are special. They are what we call standard candles. They all burn with a known intrinsic brightness. It's like if you had a collection of 100-watt light bulbs scattered across a vast, dark plain. By measuring how dim a bulb appears to you, you can calculate exactly how far away it is. These scientists were using these cosmic light bulbs to measure the expansion rate of the universe across vast cosmic distances. They were looking back in time, billions of years, to see how fast the universe was expanding then, compared to now. They expected to see the slowdown. They expected to see that gravity was winning. They found the opposite. The distant supernovae were fainter than they should have been, much fainter. The only possible explanation was that they were much, much farther away than anyone had predicted. And the only way that could be true was if the expansion of the universe wasn't slowing down. It was speeding up. Let that sink in. The universe isn't just coasting, it's accelerating. It's as if you tossed a ball into the air, and instead of it slowing down, reaching its peak, and falling back to Earth, it shot away from you faster and faster, disappearing into the sky. This wasn't just a new discovery, it was a paradigm shift. It was like we'd been living our whole lives thinking we were on a gentle, downhill bicycle ride, only to suddenly realize we're strapped to a rocket that's just ignited its engines. The discovery was so shocking, so fundamentally world-altering, that it won the Nobel Prize in Physics in 2011. And it left us with a single haunting question. What, in the name of all that is pushing the cosmos apart? We have a name for this mysterious something. We call it dark energy. And the name is perfect, because it is the ultimate embodiment of darkness and mystery. We cannot see it. We cannot touch it. We cannot detect it with any of our instruments directly. All we can see is its shadow, its monstrous cosmic footprint, in the way it bends the very evolution of reality. What could it be? This is where physics meets mythology, where data meets magic. Let's explore the possibilities. The leading candidate is something that comes straight out of the vacuum of empty space itself. We used to think a vacuum was nothing, but quantum physics tells us that's not true. At the tiniest scales, empty space is a seething, bubbling foam of virtual particles popping in and out of existence. A cosmic fizz. And this fizz, this quantum foam, should contain energy. An energy inherent to the fabric of space itself. We call this the cosmological constant, an idea that even Einstein played with, then discarded as his greatest blunder. Perhaps it wasn't a blunder after all. If this vacuum energy is real and has a positive value, then it gives empty space itself a kind of negative pressure, a sort of anti-gravity. And as the universe expands and more space is created, more of this repulsive energy comes into existence, pushing the expansion faster and faster. It's a self-feeding cycle, the ultimate cosmic engine. But there's a problem, a huge one. When physicists try to calculate how much energy this quantum fizz should have, the number they get is wrong. Not just a little wrong, it is, and I need you to understand the scale of this error, it is 10 to the power of 120 times too big. That's a 1 followed by 120 zeros. It is the single worst prediction in the entire history of science. If the vacuum energy were that strong, the universe would have been torn apart before the first stars ever formed. We wouldn't be here. So, either we're misunderstanding the quantum vacuum, or dark energy is something else entirely. Perhaps dark energy is not a constant. Perhaps it's a dynamic field that permeates all of space, a field that changes over time. We've given this idea a beautiful, almost mystical name, quintessence. In ancient philosophy, quintessence was the fifth element, the pure substance that the heavens were made of, beyond earth, air, fire, and water. It was the breath of the gods. Is our universe filled with a modern quintessence? A cosmic spirit that is evolving, strengthening, and driving the galaxies apart? Could it weaken one day? Could it change its nature? We simply don't know. It's a ghost in the equations. And then, there are the more radical ideas, the ones that sound like they're straight out of a fantasy novel. What if our understanding of gravity itself is wrong? What if Einstein's magnificent theory of general relativity, which has passed every test we've thrown at it for a century, breaks down on the scale of the entire universe? What if gravity behaves differently across these vast, empty chasms between galaxy clusters? We're trying to test this, but it's like trying to understand the rules of a game by only looking at one single tiny pixel on the screen. Or, what if the acceleration is an illusion, a trick of the light? What if we are in a special, peculiar place in the universe, a vast cosmic void that makes it look like everything is accelerating away from us, when in reality, it's just the local geography of the cosmos? It's a fringe idea, but it speaks to our deep-seated anxiety about being fooled by the cosmos. But my favorite idea, the one that truly bends the mind, is the holographic principle. What if our three-dimensional universe, with its galaxies and stars and us, is actually a holographic projection of information stored on a two-dimensional surface at the edge of the cosmos? What if dark energy is not a force within the universe, but a symptom of the projection itself? A glitch in the cosmic code? A sign that the information density of our reality is changing? Think of the universe as a cosmic hard drive. It has a finite amount of information it can contain. As space expands, that information gets spread more and more thinly. The resolution of our reality might be changing. Dark energy could be the thermodynamic cost of maintaining this illusion of a continuous, three-dimensional world. It's the energy required to keep the simulation running. This isn't just wild speculation. It's a serious area of theoretical physics. It suggests that the ultimate nature of reality is information. And what we perceive as the mysterious force of dark energy could be the signature of the projector itself. Now let's talk about the future. A future dictated by this unknown driver. If dark energy is the cosmological constant and the acceleration continues unchecked, the fate of the universe is not a fiery crunch, but a slow, cold, and deeply lonely death. Billions of years from now, the acceleration will have become so dominant that the universe outside our local group of galaxies will begin to vanish. The light from distant galaxies will no longer be able to bridge the ever-widening gulf of expanding space. They will redshift into nothingness, then fade from view entirely. The cosmos will go dark for any future astronomers. They will look up and see only a black, empty void with a handful of nearby stars. The evidence of a vast cosmic history will be lost to them forever. Trillions of years from now, even the local groups of galaxies will be torn apart. Solar systems will be ripped from their galactic moorings. Stars will be isolated in an infinite, expanding blackness. And eventually, in a time so far in the future, it defies imagination, the acceleration will become so violent that it will overcome the forces that hold atoms together. In a final, apocalyptic moment called the Big Rip, the fabric of space-time itself will expand faster than the speed of light at a local level. Galaxies, stars, planets, molecules, atoms, and even the very nuclei of atoms will be torn asunder. The universe will end not with a bang, not with a whimper, but with a silent, instantaneous shredding of reality itself. This is the future that dark energy may have in store for us. A future of ultimate isolation and dissolution. But remember, this is all based on our current, flawed understanding. The mystery is still wide open. Dark energy could be quintessence, and it could fade away. It could be a sign of new physics that will revolutionize our understanding of reality. The very fact that we don't know is what makes this the most exciting frontier in science. We are like the first humans to ever see the ocean, trying to understand the tides without any concept of the moon. We see the effect, but the cause is hidden, mysterious, and profoundly powerful. This is our cosmic quest. This is the great puzzle of our age. Telescopes like the James Webb are peering back in time, looking for more of those standard candles, trying to trace the history of the expansion, to see if dark energy has changed over the eons. We are building the biggest maps of the universe ever conceived, to see the shadow of this mystery force imprinted on the large-scale structure of the cosmos. We are hunting a ghost that holds the fate of everything in its hands. And this brings us to the most profound and personal part of this mystery. Why does it matter to you, sitting there watching this? It matters because this isn't just abstract science. This is the story of home. Our home is the universe. And to understand its fate, its fundamental nature, is to understand a part of our own story. The universe becomes self-aware, and we are now turning our gaze upon ourselves, asking the biggest questions possible. What is reality? What is it made of? And what is its ultimate destiny? The accelerating universe is a message, written in the fading light of dying stars. We have decoded the first line. It says, "Everything you think you know is wrong." The rest of the message is still waiting to be read. This is a conversation I want to continue with all of you. The mystery of dark energy is our shared inheritance as curious beings in a vast, mysterious cosmos. If this journey into the cosmic unknown fascinated you, if it sparked a sense of wonder, then please help me keep this channel going. Like this video, subscribe to the channel, and hit that notification bell so you don't miss our next deep dive into the secrets of the universe. The universe is talking. Let's listen together. And I want to hear from you. What do you think dark energy is? A force? A field? A glitch in the matrix? Let me know your most creative, your most mystical ideas in the comments below. The best ideas might just inspire a future video. For those of you who want to go even deeper, who want to explore the most radical ideas about the nature of reality, including the holographic principle, the simulation hypothesis, and the true nature of the cosmic code, I've spent years weaving these threads together in my book. It's called Holographic Multiverse, and it's a guidebook to the edges of modern physics and cosmology. If you enjoyed this video, I think you'll love the book. It's a journey to the very limits of what we know and what we can imagine. The link to check out Holographic Multiverse is in the description below. Thank you for watching, for wondering, and for being a part of this incredible journey of discovery. Remember, look up at the night sky. It's not a static painting, it's a live performance, and the main act is just getting started.